A new drug for COPD was tested in 2,500 patients and was found to increase FEV1 scores by an average of 10%. The data outcome was a normal distribution with a standard deviation of 3%. Approximately how many patients had an FEV1 improvement in the range of 13% to 16%? So this is a biostats question, and you have to understand what the normal distribution is. I'm sure you're all familiar with this graph here. It looks like this. And then this bottom part represents the FEV1 improvement. And then in the question, they tell us in this normal distribution that the average is 10%. So if I draw a line straight down here in the center, this is 10%. And you know this normal distribution is symmetric, so everything on the left side is equal to the same thing on the right side in terms of the percent of the data. So then within plus or minus one standard deviation of the average, you probably all remember that the 68% of your data falls within plus or minus one standard deviation from the average. And then within plus or minus two standard deviations of the average, you have 95% of your data. And then within 3 standard deviations plus or minus from the average, you have 99% of your data. So here I draw this line. This is minus 1 standard deviation from the average, which is 10% in terms of the FEV1 improvement. So this line here represents 10% minus 1 standard deviation from the average. And they tell us that the standard deviation is 3%. So 10% minus 1 times 3, that equals 7%. So 7% here represents minus 1 standard deviation from the mean. And then this line here represents 1 standard deviation plus from the average. So this would be 10% plus 1 standard deviation. So when 1 standard deviation is 3%, I mean it's 10% plus 1 times 3, that equals 13%. This represents FEV1 improvement. But the question wants to know the FEV1 improvement between 13% and 16%. So we have to continue on with our next standard deviation. So this line represents the average plus 2 standard deviations. So 10% plus 2 times 3, that equals 16%. So now we know what we want. We want this area between this 13% and this 16%. We need to calculate what percent of the data falls within this range, which is between 1 standard deviation and positive 2 standard deviations from the average. So I'm going to draw another line here to represent the negative 2 standard deviations, even though you don't need to calculate this, but I guess it's helpful. So 10% minus 2 standard deviations, that equals 4%. So I'm going to draw some sort of simple graphic to represent each one of these. So this, I'm going to just draw a bunch of diagonal lines to represent the between the average plus 1 standard deviation, and between negative 1 standard deviation and the average, I'm just going to draw a bunch of circles in here. And then between negative 2 standard deviations and minus 1 standard deviation, I'm just going to draw a bunch of X's in this area here. So we know that between here and here, between 1 standard deviation from the average, that equals 68% of data. And then within 2 standard deviations, that represents 95% of the data. So let me graphically draw this for you. So this average plus or minus 1 standard deviation is a circled area and the diagonal lines. And then the average plus or minus 2 standard deviations, that includes all the X's, plus the circle area, plus the diagonal line area, plus our highlighted area. So I'm going to subtract this big area here that contains all 4 of these areas minus these 2 inner areas so that I get the 2 outer edges here. So average plus or minus 2 standard deviations. I'm going to subtract that by the average plus or minus 1 standard deviation, and that will equal the 2 outer areas here. Not including the center area here. So I already told you that the average plus or minus 2 standard deviations is 95%. Minus the average plus or minus 1 standard deviation, that's 68%. And now I'm getting this outer 2 areas here. So 95 minus 68, that equals 27%. So 27% represents this X area, which is negative 2 standard deviations and negative 1 standard deviation. And then also I'm getting this area here, plus 1 standard deviation and plus 2 standard deviation in between those. So this is a normal distribution. So these 2 sides are equal. So that's why all I have to do is just take 27% divided by 2 to get just this area here. And that equals 13.5% of my data falls within this highlighted area, which is what I'm looking for. But realize that that's not the final answer, because they're asking how many patients, and we have the amount of data, the amount of patients in this range. So all I have to do is just take 13.5% of my data, times it by the total number of patients. That equals 13.5% times it by 2,500 total patients. And that equals 337.5. And that's my final answer. And you notice the answer choices, they'll be all like really far away from each other. So you just round it to the nearest number. In this case is D, 340. The reason why our number is not exactly 340 is because this 68%, 95%, 99% rule is not exact. There's actually 2 more decimal places. These here are all estimates here, this percentage of data, because this number is actually 68.26%. This is actually 95.44%. And this is actually 99.72%. But it's obviously easier to memorize just the whole numbers here, which we memorized in school. Take the actual normal distribution percentage. And remember the question here, our highlighted areas is within, it's plus 1 standard deviation and plus 2 standard deviations is what our question was asking for. So it's actually between here and here. So this area is the same thing as our highlighted area here. So 13.59%. So if I were to take, because instead of this being 13.5%, this is actually 13.59%. And if I were to multiply it by the total population of 2,500, I would get 340. So that's why I have this as like the more exact number here versus this one. If you were to memorize the actual percentage by 2 more decimal places, which is more accurate actually. But for the Naplex exam, it's going to give you an estimate. So that's why all you have to know for the Naplex exam is just the 68, 95, and 99% rule. And just whatever number you get, just choose the number that's closest to that number, because the other answer choices should be like really far off. You won't see like a choice like 335 or 337. It'll be all like really far away from each other, like 175, 880, and 1000. They're obviously like really far away. So if you have any questions, please leave it in the comments. Thank you.